Have you ever, ordered a highly sensitive digital camera and maybe a heavy office copy machine on the exact same day and wondered why they take completely different paths to get to your front door?
Oh, yeah. It's a logistical ballet that most of us never even see.
Right.
That camera might, drop out of the sky on an overnight cargo flight, while the copy machine probably spent the last month just slowly riding the waves across the Pacific inside a steel box.
It's wild to think about. Welcome to today's deep dive, everyone. We are looking at the hidden architecture of global shipping, specifically the fundamental mechanics of transportation management.
Yeah, Section G stuff for those following along.
Exactly. We're going to break down how companies design their massive global networks, how they select their carriers, how they actually route thousands of trucks mathematically, and finally, how they decode the incredibly complex world of shipping rates.
Because, as you'll see, moving goods globally is so much more than just putting a cardboard box on a truck and handing a driver a map.
It really is.
To set the stage for you, you have to realize the sheer scale of what we're talking about here. Transportation is usually the single largest expenditure in a company's entire logistics budget.
The largest. Wow.
Oh, absolutely. It's the physical link that connects the warehouse to the end customer. The ultimate goal here isn't just moving boxes from A to B. The mission is reducing total costs while simultaneously increasing delivery reliability.
Which sounds impossible.
It's tough. It requires an incredible amount of strategic planning before a single engine is ever turned on.
And I guess that strategic planning has to start at the macro level, right? Like the chessboard.
Exactly, the chessboard.
Before a company can hire a driver or negotiate a single freight rate, they have to figure out the overarching architecture of their network. They have to decide what mode of transport even makes sense for their specific products in the first place.
Yeah, transportation managers are staring at this massive, complex matrix of variables. They have to ask themselves, what are the necessary lead times? Does this cargo require high security?
Or like refrigeration, maybe?
Right. Does it need to be kept cold?
Yeah.
What's the sheer physical volume being moved, and what is the geographic distance?
Yeah.
And actually, this brings us perfectly back to your opening scenario with the camera and the copy machine.
Yeah. Why do they take completely different paths if they're both essentially just electronics going to the same house?
It comes down to a crucial concept called value density.
Okay, value density.
Yeah. Copy machines are bulky, they're incredibly heavy, and relative to their physical footprint, their retail value isn't actually that high. They have a low value density.
Got it.
Because of that, the priority is keeping the transportation cost as low as possible per unit. So they are almost always shipped in massive ocean containers from manufacturing hubs in the Far East.
Which takes forever.
It takes weeks, sometimes months, but the cost to move each individual machine is microscopic.
But the camera is like the exact opposite of that.
Precisely. Digital cameras have a very high value density. They are small, light, and very expensive. For the manufacturer, the absolute priority is recovering the money invested in building that camera as quickly as possible. Every day it sits in a shipping container is a day the capital is locked up.
So they fly by air.
They fly by air. The extraordinarily high cost of the cargo flight is completely offset by the speed of the sale and getting that cash back into the business.
Okay, let's unpack this. Wait, shouldn't you just always pick the absolute cheapest transport mode if you aren't in a rush?
You'd think so, right?
Like if the customer doesn't specifically need that camera tomorrow, why wouldn't a company just default to the lowest price tag on the shipping quote every single time?
It is incredibly tempting to look at it that way.
Right.
But that is a trap that catches a lot of novice logistics planners and, frankly, a lot of finance executives.
Really?
Yeah. You have to look at the total supply chain cost, not just the direct freight bill. There's this really fascinating study done by Penn State University that compared rail transport versus road transport to illustrate this exact point.
Oh, let's hear the numbers. Because rail is notoriously cheap, right?
Cheap. On the surface, in this study, rail looked like a massive bargain. It was only $3 per unit for the direct transport cost.
Okay, and road?
Road transport, on the other hand, was $4.30 per unit.
So, on a spreadsheet, that looks like a clear win for the trains. You save $1.30 every time you ship a single unit. If you're moving 1 million units, that's over $1 million saved. Why would anyone choose the trucks?
What's fascinating here is that higher direct transport costs can actually save you money across the total supply chain.
Wait, how?
When the Penn State researchers factored in the hidden indirect costs, The entire picture just flipped upside down.
What kind of hidden costs are we talking about here?
Well, first you have inventory carrying costs. Rail is significantly slower than trucking.
Right.
That means your products are sitting in transit for days or weeks longer, your capital is tied up, and you're actually paying interest on it.
Oh, wow.
Second, rail transit is rough. Train cars bang together. It's actually called humping in the industry, which means you have to spend significantly more money on heavy-duty packaging just to prevent damage.
Oh, that makes sense. A truck rides on air suspension on a highway, but a train is literally just metal wheels slamming on metal tracks.
Exactly. Then you have to add in the additional warehousing required because rail deliveries are bulkier and less frequent.
Okay, that adds up.
And finally, they calculated the cost of potential lost sales due to slower transit times. Like, if the product isn't on the shelf, the customer just buys a competitor's product.
So when you tally all of that up, what happens to that $3 freight bill?
When you add all those hidden expenses, the rail's total cost jumped to $15 a unit.
15.
Yeah. Meanwhile, road transport, because it was faster, required lighter packaging, and needed less warehouse buffer stock, remained cheaper overall at $13 a unit.
Wow. So by trying to save a buck on the freight train, you actually lose $2 in the warehouse. That is wild. It really highlights how you just can't make these decisions in a vacuum. The mode you choose ripples through the entire company.
Precisely. Which is why mode selection is this deeply analytical first step.
Right.
But let's say you've done the math. You know you are shipping by road because the total supply chain cost dictates it.
Okay.
You still have to figure out who is going to show up and drive that truck.
Right. And you can't just, Google big truck for hire when you're a Fortune 500 company moving millions of dollars of freight. How do they actually sort through the hundreds, sometimes thousands of carriers out there?
It is a highly structured, very strict funnel process. It all starts internally with a document called an SOW, or Statement of Work.
Okay.
This defines your exact non-negotiable needs before you ever even speak to a carrier.
What goes into an SOW? Like what kind of detail?
Oh, everything. What specific geographic lanes are you running? What is the daily frequency? Do you need refrigerated trailers?
Okay.
Do the drivers need hazardous material certifications? You are building a concrete profile of the job.
And once you have that profile, you go out to the market.
Yes. With an RFI, or request for information, this is casting a very broad net. You might send this RFI to 20 or 30 different logistics providers.
Just to see who's out there.
Right. At this stage, you aren't even asking for prices. You just want to know, are you mechanically and financially capable of doing this job?
So you're just filtering out the companies that, don't have enough trucks or don't operate in the right states?
Exactly. And from those 20 or 30, you filter down to a short list of maybe 5 to 10 carriers.
Okay.
These are the ones who receive the RFP, the request for proposal, which is sometimes also called an ITT, invitation to tender.
And this is where the actual money gets discussed.
This is where it gets highly competitive, yeah. You ask for specific pricing matrices, detailed service level agreements, and you often host bidders conferences.
Bidders conferences.
Yeah, the carriers come in, they ask incredibly detailed questions about your loading docks and your seasonal volume spikes. They might even do site visits to your facilities just to see how efficiently you load trucks.
It sounds a bit like corporate dating. Like the RFI is the dating app swipe, the bidders conference is the first date, and the contract is the marriage.
That is a brilliant analogy. I love that. And in logistics, that marriage is the contractual rate. In fact, about 80% of all commercial freight moves under contractual rates rather than the spot market, which would be, just grabbing a random truck for a day.
But 80% is massive. If the spot market fluctuates, why wouldn't shippers just hunt for a bargain every single day? Why lock yourself into a marriage contract like that?
Because in the global supply chain, stability is exponentially more valuable than a temporary bargain.
Really?
Yeah. Think about booking a hotel room. If there's a massive convention in town, a $100 hotel room suddenly costs $500. If you're a manufacturer, you cannot run your business if your shipping costs quintuple overnight, just because there's a sudden shortage of trucks in your region.
You need the predictability of like a long-term apartment lease.
Exactly. For the buyer, the shipper, a contract guarantees capacity. You know the trucks will physically be there when your factory produces the goods.
And for the carrier?
For the carrier, it guarantees stable, predictable volume. They can plan their labor force, buy new equipment, schedule maintenance, all because they know that revenue is locked in for the next year.
That makes perfect sense for stability. But it also introduces a really interesting dynamic with pricing and demand. I was actually reading through the source materials about how the market reacts to shipping rates, and they brought up this economic concept of demand elasticity in shipping.
Yes, and it behaves in a very specific, slightly counterintuitive way in transportation. Overall demand for freight transport is highly inelastic.
Okay, let me make sure I have this right. That means if a massive trucking company suddenly slashes their prices by 50%, a television manufacturer isn't going to magically produce twice as many TVs just to take advantage of the cheap shipping.
Exactly. The shipping cost doesn't drive consumer demand for televisions. The overall pie of freight that needs to be moved doesn't get bigger just because shipping gets cheaper.
So the carriers can't artificially create more freight by lowering prices.
No, they really can't. However, while overall demand is inelastic, substitution is highly elastic.
Meaning swapping one carrier for another.
Exactly. If you are a logistics manager moving those TVs and carrier A is charging you a premium, but carrier B drops their price and offers the exact same service, the same speed, the same reliability,
Yeah.
you will absolutely ditch carrier A and substitute them with carrier B in a heartbeat.
So even though the market size isn't growing, the carriers are in this brutal, constant street fight for market share.
Which is exactly why maintaining that relationship, that contractual lease, is so critical for both sides. But, securing the contract is really just setting the table. The meal still has to be cooked.
Which means someone actually has to manage the daily chaos.
Oh, yeah?
We've selected our mode, we've contracted our carrier, but whether we are using an outsourced partner or our own in-house fleet, someone is responsible for routing and scheduling to ensure those trucks are moving efficiently.
This is the engine room of logistics, and it's where technology completely takes the wheel. The industry relies heavily on a TMS, a transportation management system.
A TMS.
Yeah, this isn't just a basic tracking app on a phone. It's a massive, complex algorithmic software platform that mathematically optimizes load tendering, routing, rating, and tracking in real time.
The sources mention that implementing a good TMS can reduce a company's freight costs by 6 to 10%. I mean, when a major retailer is spending hundreds of millions on logistics, 10% is an unbelievable amount of money.
It is game-changing. And the TMS achieves this because manual routing simply breaks down at scale.
How so?
If a dispatcher is managing 3 trucks, they can look at a map and figure out the best routes. If a dispatcher is staring at a screen of 300 trucks with thousands of different delivery windows, varying weight limits, driver hours of service regulations,
It's just too much math.
a human simply cannot calculate all those variables.
So what exactly is the TMS doing that the human can't? How does it actually optimize the route?
It focuses relentlessly on 2 core route planning principles. The first is maximum drop density.
Grouping deliveries by close physical proximity.
Right. The algorithm prevents a truck from dropping off a pallet on the north side of town, driving all the way to the south side for the second drop, and then driving back north for the third.
Right, that would just be a waste of gas.
Exactly. It clusters the drops to minimize total mileage.
And what's the second principle?
Full use of vehicles. The TMS calculates the dimensions and weight of every single box to ensure every square inch of that trailer, right up to its legal weight limit, is utilized. Shipping empty air is the most expensive mistake in logistics.
So wait, what does this all mean for the return trip? If the TMS brilliantly packs the truck full of goods and it drives 500 miles to drop them all off, does it just turn around and drive 500 miles back completely empty?
If it does, that is called deadheading, and it's a massive, crushing drain on profitability.
Deadheading, okay.
Yeah, you're burning diesel, paying a driver, putting wear and tear on an engine just to move a box of air. The ultimate goal of fleet management is to completely eliminate deadheading through a practice called backhauling.
Give me a scenario. How does backhauling actually work in practice?
Let's look at a major national grocery retailer. They load up a refrigerated truck at their central distribution center and send it out to restock 5 local supermarkets.
Oh.
Once that truck makes its final drop at the last store, it is completely empty. But it doesn't just drive back to the DC.
Because that would be deadheading.
Right. Instead, the local stores load that truck up with empty wooden pallets, reusable plastic delivery totes, or maybe even crushed cardboard bales for recycling.
Oh, so they are essentially getting a free ride back for all their operational material.
Exactly. They completely eliminate the need to pay a separate third-party trucking company to ship those pallets and cardboard back to the warehouse.
That's incredibly smart.
The TMS orchestrates all of this. And if it's a dedicated carrier fleet, the TMS might even find a backhaul opportunity by contracting to carry a load for a completely different, unrelated company on the return trip.
Wow.
Anything to generate revenue while moving that truck back to its starting point.
It really is a giant moving puzzle. Which brings us to the final piece we need to understand today, decoding the price tag itself.
Yes, the bill.
We are successfully routing our optimized fleet, we have our contracts in place, but eventually the invoice arrives. How do carriers actually calculate the price of a shipment? By normal logic, it seems like it should just be miles driven multiplied by the weight of the box.
It is definitely not that simple, unfortunately. Assigning a rate tariff is generally a complex two-step process. First, you have to determine the freight classification of the product itself.
Okay.
And then second, you apply the specific weight, the origin, and the destination to that classification.
Let's talk about that classification, because this is where the hidden rules of shipping live. In the US, for example, the NMFC, the National Motor Freight Classification System, categorizes every single physical product into one of 18 distinct classes.
And those 18 classes aren't arbitrary. They are determined by 4 highly specific drivers: density, stowability, ease of handling, and liability.
Okay, let's break those down. Density is obvious, right? How heavy it is relative to its physical size. Like a box of lead is dense, a box of feathers is not. Stowability is how well it stacks. A perfectly square, uniform cardboard box stows perfectly. A weird, jagged piece of farming machinery doesn't stow well at all because you can't put anything on top of it or next to it.
Which means it wastes space, which increases its class and its price.
Right. Then there is ease of handling. I imagine this isn't just about weight.
No, it's about mechanics and safety. If you are shipping standard pallets, a forklift can move them in seconds. That's easy handling.
Sure.
But what if you are shipping oversized, fragile panes of architectural glass? Or hazardous chemicals that require specialized driver training and spill containment gear? The harder it is to physically interact with the freight, the higher the price.
And the final driver is liability, which is essentially just risk.
Precisely. Shipping a pallet of cast iron anvils has almost zero liability. You can't break an anvil and nobody's going to steal it.
Unless you're a cartoon coyote.
Exactly. But if you are shipping a pallet of crystal chandeliers or high-end microchips, the risk of damage or theft is astronomical. The carrier takes on that risk, so the classification class shoots up.
Here's where it gets really interesting. I want to throw a wrench into this math.
Okay, let's hear it.
What if I'm shipping something incredibly light, but it takes up the entire truck? Let's say I'm shipping a massive load of loose ping pong balls. They weigh practically nothing. By normal weight-based logic, it should be basically free to ship, right?
If we connect this to the bigger picture, you have to understand that carriers only really have 2 commodities to sell you: weight capacity and cubic volume. The golden rule in the industry is that trailers will cube out before they weigh out.
Meaning you will physically run out of space inside the rectangular box of the truck long before you hit the maximum legal weight limit on the vehicle's axles.
Yes. So for your ping pong balls, the carrier is absolutely not going to charge you by the pound. If they did, they'd go bankrupt. Instead, they will use what is called a cube rate.
A cube rate.
Yeah, this prices the shipment based entirely on the physical volume of space it occupies.
Because by filling the truck with ping pong balls, you've prevented them from putting anyone else's freight in that space. You didn't buy the weight, you bought the air inside the truck.
Precisely. You see this taken to the absolute extreme in air freight, where space is at a massive premium inside an airplane fuselage.
Oh, I bet.
They use density rates, which calculate a highly complex formula of dimensional weight to ensure the airline is being properly compensated for the space the box takes up, not just the physical weight on the scale.
And hovering above all of these classifications and cube rates and TMS algorithms is the great unpredictable variable of the logistics world: fuel.
Oh, fuel. Fuel costs are the most volatile driver in transportation pricing.
Oh.
And what's crucial to understand is that it impacts the different modes of transport in drastically different ways. High diesel prices have a heavy, immediate, and brutal impact on road freight. A spike in global oil prices directly hits the trucking company's bottom line, which instantly results in fuel surcharges being passed on to the shipper.
But the railways aren't hit as hard.
They are far less affected.
Yeah.
Because a single freight train can haul the equivalent cargo of hundreds of trucks, the fuel cost per unit is a much smaller percentage of a railroad's overall operating expenses.
So how does a logistics manager react when oil prices suddenly double?
You see a massive strategic shift. When diesel skyrockets, Shippers scramble to move their long-haul freight off the highways and onto the rails just to escape those crippling truck fuel surcharges.
Wow.
Which perfectly proves why having a diverse, flexible network design from step one, from the very beginning of our conversation, is so incredibly crucial.
It always comes back to that initial chessboard. We've covered an unbelievable amount of ground today. We've seen that transportation management isn't just about handing a box to a driver and waving goodbye.
Definitely not.
You are constantly balancing the speed of delivery against the total supply chain costs. You are treating carrier relationships like high-stakes corporate leases. You are deploying advanced mathematical TMS software to squeeze every ounce of efficiency out of a trailer to avoid deadheading. And you are navigating a maze of classifications, cube rates, and fuel volatility just to understand your final bill.
It is a dynamic living system that is constantly evolving. Which actually brings up an important question for you to consider long after this deep dive is over.
Oh.
We've talked extensively today about how geographic distance, human labor costs, and traditional diesel fuel dictate our current mode selections and our complex rate structures.
Right, the fundamental rules of the logistics game as we know them today.
But look at the horizon. We're moving rapidly toward a near future filled with autonomous, driverless trucking networks running on electricity and fleets of automated airborne delivery drones.
It's true.
When you strip human labor costs and volatile diesel fuel out of the equation entirely, how will that completely upend the total cost math we rely on today? Will the ultimate mode selection matrix, the very foundation of how we move goods around the globe, have to be completely rewritten?
A completely new chessboard. That is a brilliant thought to leave on. Thank you for joining us for this deep dive into the hidden world of transportation management. As always, keep questioning the systems around you, keep exploring, and the next time you order a digital camera and a copy machine on the same day, you'll know exactly why they take the long way home.